All right, 7.1. Today we're going to talk about finite decimals. This section is called an Introduction to Finite Decimals. So a little bit of vocab first. The word decimal comes from the Latin word meaning 10. And we don't often use very good proper mathematical language when it comes to decimals, but there is proper mathematical language that we're going to be practicing using. So when we look for these decimal places, I'm going to do two decimals or two values before the decimal place, and I'm going to do, I think it's 5 afterwards, 6 afterwards. All right, each of these locations has a name. So we're going to start in the far left, and the far left, this is the tens place. And then this one is the ones place, or you can say the units place. They're both used interchangeably for that location. So the tens place and the ones place. So after the decimal, that one you probably know. What's that one called? Tenths, yeah. So this is the tenths place. So it mirrors what's going on the left-hand side, if you skip over the unit. But you put the THS on the end of each of them. So we have the tenths place, and then we have the hundredths place. Do you know what the next one is? Mm-hmm. Thousandths. What about after the thousands? Yeah, so we go to the tens of thousands, so 10 thousandths. After the 10 thousandths? Uh-huh, 100 thousandths. Yeah, spaces. The last one that's here on my screen anyway. Millions? Yeah, it is millions. And we could keep going. Right, we keep going indefinitely. We've got 10 millions, 100 millions, and we'd have billionths and so forth. For the purposes of what we're doing, I think this is far enough. I think their 10 millionths might come up in here in like a group work or homework problem or something, but nothing bigger than that I remember. So what we're going to want to do is we're going to be able to take a written out numerical value and write it properly in words, and then go the other direction. Take something that's written out in words and write it properly in numerical value. So this number, we would probably mostly say, most of us would say something like this, 32.4236. Who says that? Me too. I do it too. I hear every now and then somebody say the point is a dot now. Thank you to the internet, right? Dot, yeah. I do hear that occasionally as well. So mathematically, however, the decimal point indicates a change in the way we say things. So we say something before the decimal point in one way, and then after the decimal point in another way. So the before the decimal point part, what is that number? We usually say that one right. That's 32. So we'll say 32. And it does have a hyphen in between. I'm not super picky about the hyphens. I think hyphens are a little tricky on where they show up and where they don't show up sometimes, but there is one between this 30 and the word 2. The decimal point is read as the word and I will forever remember that because I used to get in a lot of trouble when I was in elementary school for saying numbers like this as 432. My teachers did not appreciate it when I did that and would let me know it. So the and is the decimal place sort of language piece, okay? And then after that, what we do is we take this number and we write it out in words first as though it's independent of the other number. So this number is 4,236, right? So that's what we're going to write down. We're going to write down 4,236.
It's hard for my brain not to write, actually.
And after we've written the word out representing those 4 digits as they are a 4-digit number, we have to indicate the place value that they end in. So I need to know where the 6 is located. What is the location, right, from this like a description, this expansion we did, of the 6?
10,000.
It's 10 thousandths. So that's the last thing we write, is that this is the 10 thousandths. So we have 32 and 4,236 10,000ths. That is properly written with mathematical context. That's correct. Now, that idea we can do and take the other direction. So we have the number 536 and 76 thousandths. So it's a good idea to maybe circle the and, so you can separate where the decimal is, the before and the after. 536, what does that look like? 5, 3, and a 6, that's right. Now, after that, we have the number 76, which is 7, 6. But it has to end in what location? The thousandths location. How many decimal places is that to the right? It's 3. So we need to make sure that we have 3 decimal places and the 76 is ending those, which means what's going to go in the one that I skipped? A 0. Yeah, it's going to be a 0. So written more cleanly, I have 536. I've got the decimal point, and then I've got 076. Okay? All right, so for the most part, I try to do what the book does, right? So even if I don't really care for it, we're going to deviate from that with the next example, and I'm going to show you why, and there's a really good reason why, or we wouldn't be deviating. We're going to take a look at base 10 expanded form. So very much like I wrote out those place values before, I'm going to write them out here. I'm just going to write out a few different ones to show an example of something. So what I'm going to write out, instead of writing out the words, like I did last time, is I'm going to write out the place value, like how much it's worth in a numerical form. So the first one is the hundreds place, so it's worth 100, right? Anything in that place is worth 100. So you put a 5 in that place, it means it's 500. You've got the tens place. It's fine. You've got the ones place. After the decimal, we called it the tenths place, and we're going to write it in fractional form. This is a tenth. And we had a hundredth. So 1 over 100, and we have the thousandths, so 1 over 1,000. Okay, is that all right? Okay. So the note on here is what I want to make you aware of. Your book uses negative exponents. So where I would write out 1 over 100 as the hundredths place, they would write 10 to the negative 2. It's not that it's wrong, it's a different perspective, but I think you lose the context, at least some, when you do that, and I don't want you to lose the context of what's happening. So we're about to write something out in expanded form, but when we write it in expanded form together in class, it's not going to look like what your book does. And when you go and you check your answer in the back, it's going to look different as well. And I expect that it will, and it should, okay? Because I want you to write this with this notation so that we keep the real understanding of what the value is of each of those places. So when we write out this number in expanded form, first of all, can somebody read it for me properly?
100 and
You did it too. Try again, Lauren. It's okay.
103 and 300.
Very good. 103 and 300ths. Is everybody good with that? 103.03, right? Yeah, okay. So 103 and 300ths. Okay, so here's what we're going to write in the expanded form. So each of these places is going to be written as a multiplication factor. So the first one's a 1. So we're going to write 1 times 100. If you skip the 0, it's okay. I'm going to write it out just so that I've covered all of them. You've got 0 tens, 3 ones. You've got 0 tenths, so that's the 1/10. And you've got 3 hundredths, so that's 3 times 100th. And this is what expanded form would look like. If you don't want to put parentheses around the places, you can put a dot between them. That's okay too. It doesn't matter, but something to indicate that they're being multiplied and that we're separating each place value by addition. Okay? So this is what a base 10 expanded form looks like. Decimal square grid. A decimal square grid is a grid that's 10 by 10. So 10 rows, 10 columns, so therefore it would contain 100 squares. And we're going to draw one. Yours is probably going to look better than mine because it's hard to get it to do what you want to do in the right sizes when you're working on the iPad. So we're going to try, but we're going to make 10 rows and 10 columns, at least that's our goal. Well, I think I've definitely drawn worse grids in my time, so we'll go with that one, okay. All right, so here's my grid containing 100 squares. If it's 10 by 10, each of those place values, or each of those boxes now is worth a place value in the hundredths place. So if I were to shade in, say, one little box, this little box is worth 1/100th because it's one out of the 100 different grid box pieces, okay? Another way to sort of think about this whole idea of 1 out of 100 is to do coins. So if you have pennies, which are really cheap, so even if the kids steal your pennies, you're not out that much, right? Pennies, if you had 100 pennies, and you talk about one penny being worth the amount of 1/100th of a dollar, that's another visual that can be used that might have some relevance to the students. So we're going to take our decimal grid, and we're going to draw 24 hundredths. That's what this is. Now, technically, you can shade in 24 of any boxes you wish. It's going to be really not very friendly to me or to the grader if you decide to randomly shade in 24 boxes. Just saying. So we're going to shade in, whoops, I thought I had a highlighter going. We're going to shade in these 10, and these 10, and 4 more. And that would be 24 hundredths, so that we're kind to everyone, right? Be kind to the grader. So this would be 24 hundredths decimal grid shaded in. And it doesn't have to be on the left-hand side. It can be the top of the box or the bottom of the box or the right-hand side. That doesn't matter. It's just that they're, easy to count, contiguous to one another. Now, we've talked before in Chapter 6 about the fact that some fractions have really nice decimal forms. And so we sort of gravitate towards wanting to use decimals in that fashion. And there's some decimals that don't have very nice decimal forms. And that's a lot of what Theorem 7.1 is kind of getting at. So a rational number, a over b, in simplest form, can be written as a terminating decimal. Terminating means it stops. A terminating decimal, if and only if the prime factorization of the denominator contains only 2's and 5's. So there are a couple of conditions here that you have to be aware of. The first is that it's in simplest form. So whatever your fraction starts out in, you got to put it in simplest form first. Don't start factoring and looking at denominators right away. First, simplest form. And the second thing is it says only 2's and 5's does not mean that it has to have 2's and 5's. It simply means it can't contain anything else. So no 3's, no 7's, right? Nothing like that. It can only contain 2's and or 5's, nothing else. So we're going to take a look at some examples where we're really being asked, at least at the start, is it a terminating decimal or not? And then after we know that it is or it isn't, then we're going to find the form of that decimal, whether it's terminating or whether it's repeating. Actually, no, only if it's terminating are we finding the decimal expansion. Sorry about that. All right, so the first one, 9 over 24. So the first step as we work any of these problems is that we want to make sure they're in simplest form. It's not in simplest form. What does it need to divide by? All right, so 9 divided by 3 is, and 24 divided by 3 is 8. Is it in simplest form now? Yes. So at this point, we would take the 8 and we have factored. 8 factors how? 2 and 4, and then 4 factors as 2 and 2. So my factorization of my simplified denominator is 2 times 2 times 2. Will this decimal terminate? This was our description. Yes, it will terminate. Why? Yeah, the denominator only, we only care about the denominator, we don't care about the numerator. The denominator only has only 2's in it. And it can contain 2's, it can contain 5's. Ours has 2's only. So yes, this will terminate. So this one terminates. What that means is that I'm going to write out my decimal division, right? So I'm going to take the numerator, and I can use the reduced version. It'll be easier if you use your reduced simplified fraction. It'll work with the other one, but it'll be harder to do. So the 8 will go into the 3. All right, we've been doing lots of decimals at my house lately with my 8th graders. So we look at the 8 and we say 8 does not go into 3, right? So we put a decimal point after it and put it a 0, and the decimal point comes straight up. Now we treat the 3.0 underneath the division bar as though it says 30. And and we ask ourselves how many 8s go into 30? And the answer is 3. We put a 3 above the 0 because we put it all the way into the number 30, and that's where the 30 ends. 3 times 8 is 24, and we subtract. So what is 30 minus 24? 6. As long as this has a non-zero number, when I subtract, we got to keep going. So I just put another 0 on the end, and I bring the 0 down. Now I have 60. How many 8s go into 60? 7. 7 times 8 is? And if I subtract, I get 4, which means I'm not done. So I'll put another 0 and bring it down. 8 goes into 40 how many times? 5. So I have 5 above my last 0 that I incorporated. 5 times 8 is 40. So we are done. We're at 0 at the end. And the answer to our question then, sorry about that. The answer to our question is right here. So it's 0.375. If you want to put a 0 in front of that, like 0.375, that's fine. Doesn't matter. Either way will work just fine. How about B? Is it in reduced form? Nope. What can we divide by? Divide by 2. I get a 5 on top. And what do I get on bottom? Yep. Okay, is 5 over 12 in reduced form? Yes. So now what do I do?
You factor around the 12.
Yeah, I factor the 12. So if I factor the 12, what do I get?
2 and 6.
Okay, 2 and 6, and 6 is?
2 and 3.
2 and 3. So these are the pieces I'm looking at. What do they tell me?
You cannot terminate.
It is not terminating. How come?
Because there's a 3 in it.
Because there's a 3 in it. You're right. So this one's a no. It is not terminating. So we're going to look at the size of decimals next. That is really tricky for kids a lot of times. And so when we're looking at the size of decimals, we want to be able to do that. One of the ways anyway that's nice to do that is by lining the numbers up vertically, sort of like one on top of another, okay? So if we line the numbers up by place value, then it means all the ones places are together and all the tens places are together. I should have said tens and then ones, and then the tenths, and so on down the line, the hundredths and so forth. And we read from left to right. So we start on the leftmost value to decide, are they different or are they same? And if they're the same, we keep moving until they're different. And as we move, we compare the different digits. Are they bigger, are they smaller? Can I stop? Do I have to keep going? So we're given an example like this, 4 different numbers that are all really close together, right? I mean, like if you were rounding any of them, they'd be 13.49 every single one of them. Like they're negligibly different, but they are different. So we're going to do what I suggested on the previous slide. We're going to line them up. So I'm going to write them again even because then I can write them a little bit bigger. So 13.4919. The next one is 13.492. Then I have 13.49183. And the last one is 13.49199. Okay, so before the decimal place, what is the number before the decimal place in all of them? 13, so I don't really care about that. The tenths place is 4 on every single one, and the hundredths place is 9. So the first place that I can go where they're actually different is in the thousandths place over here. Right? That's the first place they differ. And we actually see that one of them is not like the others. Right? Which number is different? The one that has a 2 in it. And is it different bigger or different smaller than the other ones? It's bigger. It's bigger because it's 2 and the others are all 1s, right? So if we're going to label them, it says least to greatest, so this one would be our last one. Oops. We'll call it number 4 in our list because it's the biggest one. We can ignore it now. It's going to be the last in our list and we can ignore it. All right, with the numbers that are left, I look at the next place value, the 10,000ths place. And what do I notice? The 8. And what is it about the 8 that's different? Like, is it bigger or smaller? Yeah, it's smaller. So since it's smaller, that means it's actually the first one, right? It's the smallest one. So this was a number 1. All right, now I'm on to the last one. Well, the last pair, which then is comparing the last digits. So here, there's nothing in that top place. So what does it mean really there? It means there's a 0. So I have an understood or sort of a non-operational 0, ending 0 there. So that 0 compares to my 9 at the bottom. Which one makes it bigger?
The 9.
The 9's bigger. So the 9's bigger, and we were doing least to greatest, so that would be a number 3. And the first one was number 2. Is that right? And then it says we're going to put them in order from least to greatest. So you can either write them out left to right with some commas, or you can use some symbols like this. So I like to use the less than signs. So I have 13.49183 is less than 13.4919 is less than the third one, 13.491949. Hang on. 13.49199. And then my last one is the number 4 one. Actually, I think I might be able to fit it over there.
You'll take either commas or.
Yep, I will. You bet. The last one is 13.492. Okay, is that all right? Cool. Last question for today. I told you this was a brief lesson by comparison to the others. Have you heard the word tithe before? Yeah? What does the word tithe mean? Okay, a percentage. Any specific percentage, Kate? 10%. It is 10%. Okay, so tithe has the meaning of 10%. How is that related to decimals?
10% would be like 0.10.
This is equal to 0.10 of a decimal. And some other ways to describe it, based on the language we've been using, is that this is 1/10, right? That 1 in the 10th place is 1/10. And specifically in our Christian faith, 1/10 or the tithe is referred to in the Bible, and it's talking about of our income or of our increase is how they usually describe it. So in practice, we can take our income, so say that you made $50 babysitting, and the tithe on that would be what?
$5.
Would be $5, which is 1/10 of 50. So every now and then, sometimes people will use the word tithe interchangeably with offerings, and they don't even necessarily know they're doing it. They'll say something like, I give a 5% tithe. That doesn't make sense, right? Tithe has its own meaning. You can say give a 5% offering, that's fine, but there's not a 5% tithe. Tithe is 10%. That's what it actually means.